So now we'll get into vocabulary. See, like when you go to China, when you want to learn Chinese, you start with the vocabulary, right? Okay. When you go to Japan, when you go to other this thing. So similarly, Six Sigma has got a vocabulary. Let's see some vocabulary. So I'm going to go step by step. Vocabulary. How many of you have seen the signs? What does this sign represent? There are two signs on the screen. What are these two signs represent? All right. The first one, summation, is called capital sigma and small sigma. Now, as you rightly said, both are Greek letters. That's right. As you rightly said, the bigger one is actually also called sigma. Sigma, so and so. The mathematician will use this, okay? Capital and small, correct. Okay. But then what we use in Six Sigma is the small one, which is called variation. Okay. So this is a Greek letter assigned to represent the amount of variation or inconsistency or exhibited by measurable outcome. Okay. So let me bring in lean terminology here. What is the Japanese word for variation? In Kaizen, we use 3M, right? Muda, Mura, Muri. How many of you have heard about this? Muda, Mura, Muri. And this is a question to all of you, okay? Which of these components is actually represents sigma? So Muda means waste, Mura means variation, and Muri means overburden. Okay, so we are talking about both lean and Six Sigma here. So in lean terminology, we use elimination of waste, Muda, Mura, Muri. Okay, and Mura is variation here. Variation synonyms are inconsistency, unevenness, imbalance. So Mura is variation, and Muda will lead to Mura, and Mura will lead to Muri. And that is why it's called lean Six Sigma. If you don't eliminate waste, more waste will cause more variation. More is Muda, more is Mura. Muda is waste, that will lead to Mura. More is a waste, that is Muda. The more is a variation, which is Mura. And then it will lead to Muri. The reason that I'm bringing the sigma, because we are talking about lean Six Sigma. In lean, that is why we first reduce waste or eliminate waste and then try to reduce the variation. So, okay, some question here, okay? Can the variation be eliminated? Variation can never be eliminated. It can only be reduced. It can never become zero. Okay? Variation can never become zero. There will always be variation. The only thing is the measuring equipment should have the capability to detect that variation. Okay? So let's go to the next vocabulary. What is Six Sigma system? Enterprise-wise strategy. Six Sigma is not, should not be treated as just one local process improvement. Many of them do Six Sigma in a particular, improving a particular process, that is absolutely okay. But the master black belt, who knows the strategic objective of the organization, he will find out which are the bottleneck areas, and he will eventually create projects which may be related to a particular process. All the projects should ultimately lead to the strategic objectives of the organization. That is why it is called enterprise-wise strategy, that recognizes the problematic areas of the business. Okay, we can call bottleneck operations, bottleneck areas, problematic. Defines the improvement efforts and determines and implements data-driven. We saw it is data-driven, breakthrough level solutions in a predictable and repeatable manner. Okay. Now, there are few words that you'll have to catch here. Enterprise-wise strategy. It is not localized. Okay, that must be clear to you. And you'll have to focus on the problematic areas and not improve everywhere. Where it matters the most, that's where you'll have to catch. And it defines the improvement effort. For example, what is the current state and what is the future state? And it is data driven. Okay. And then it is almost like a step change that we can bring. That is, it's not like Kaizen, which is continuous improvement or continual improvement, but it's a breakthrough level improvement. We call it as a step change. In Japanese word for that is kaikaku. Okay, that's a breakthrough level of improvements in a predictable and repeatable manner, consistent manner, which means that with the proper methodology, we can keep on rising the bar from one step to the other. Finally, this improves the business results. Okay, let's go to the other vocabulary. And before that, I wanted to give you some components in the, the entire system of Six Sigma, in the DMAC, what we saw. We will talk about process maps, benchmarking, inferential strategies, process capability, process documentation. In define phase, we will go into the depth of project charter, critical to quality, performance standard. In measure phase, we'll talk about measurement system analysis. Okay, it's very, very important. And how to collect data, plan the data, and all that stuff. And analyze, okay, what is the required quality, the entitlement quality, and we will see the sources of variation. We will get into root cause analysis. We will organize the causes and then get into analysis of this process. And then improve. Okay, establish the transfer function from what level to what level that we are going to transfer. And finally, after we implement, how do we sustain that? What are the control methods that we use to sustain that? Okay, now let me get back to vocabulary again. Okay, this is a high level view. And again, I'm coming back to vocabulary. Often we will use this word called variable in Six Sigma. Okay, we'll call variable. And most of us, we know whatever is varying is called as a variable. Okay, but we will call continuous data, discrete data, ordinal data. Okay, variable. A naming for a group of items that are used as a part of equation or systems or situations. For example, if you have a fever, let's say, what are the factors that make your sugar level high? Let's see what are the factors. Okay, if your sugar level goes high, body sugar level I'm talking about, what might be the various factors? This is a general question which all of you can understand. Okay, so many things are varying. That is why your sugar level are high. Okay, nothing is consistent. Our eating habits are not consistent. Our daily routines are not consistent. The exercise is not consistent. Okay, nothing is consistent. That is varying. That sugar level is also varying. Okay, similarly, the ambient temperature. The ambient temperature or the room temperature. What causes the variation of these temperatures in the ambient temperature? I'm just giving an example for a variable, okay? Because later on I call y is equal to f of x, the excess variable, then you'll be blown out. Okay, I don't want anybody to, heat, humidity, moisture, number of people in the room, and the type of operations happening in the room, etc., etc. There are so many things, factors that can vary the temperature of that particular room. All right. So to bring the temperature to control, you will have a control method. And what is that control method? To bring the temperature of the room under control, you will have AC, air conditioning, right? And there, automatic controlling of the temperature based upon very varying. So whatever it varies, accordingly, you have a control system. All right. As the name implies, the value or the amount can be varied for the item. Here I have given one example. Salt is a variable for an ingredient in the soup. Okay. Now, can you put the accurate amount of salt for the soup every time that you make the soup? Is it possible? Even if you have the highest form of technology, can you add the same quantity of salt? Okay. So this means that, it might look like the quantity is same because you don't have a sensitive equipment to measure that. We call it as a least count. Okay. I don't want to use the word least count. Okay. So it might vary to the second decimal place or third decimal place, etc. And so this is called as an input, which is the terminology that will be used in this course. Word y is equal to f of x, which means y is the effect and x's are the causes. Okay. So for your body weight, if the weight of your body. Suppose if it's an obese person and that is the effect. I'm overweight is Y. And what are the causes for overweight? Several other reasons. The amount of ghee that you're taking, the amount of exercise that you're doing, etc., etc. So X1, X2, X3, X4, X5, X6, whatever it is, then we'll have to identify which are all the critical X's that are variable and try to focus on the main X's so that your weight can reduce. Okay, the other vocabulary is a problem. In Six Sigma, we use a vocabulary called as a problem. How do you define a problem? What is mean by a problem? When something does not work as well as expected and is insufficient, yet creates another problem, or something we would prefer to avoid. And these are some of the definitions that you say. But in Six Sigma, we say there is an expectation, there is an actual. The gap between the actual and the expected is called as a problem. For example, I want to be 65 kgs in weight and I'm currently 85 kgs in weight. The gap between my expectation, which is 65 kgs, and the actual, which is 85 kgs, is a problem. I want to have a sugar level of 120, but the actual sugar level is 220. The gap between the expected, which is 120, and the actual, which is 220, is a problem. And then data. So this is one vocabulary we can never miss out in Six Sigma because it's a data-driven methodology. Data, what does data mean? So data is a factual information. Factual information, not fake information, okay? Based on which we do the analysis, we do the reasoning, we do the discussions, we take decisions. So data comes from some sort of measurement and most useful when it is numerically quantified. Most useful, not all data can be numerically quantified. Suppose if I ask all of you, how are you feeling now? What answer will you give? Great, fine, super fine, good. Suppose if I want to convert that into numeric, on a scale of 1 to 10, 9 or 10 feeling very happy, and 1 or 2 is very sad, and 5 or 6 is okay feeling, give a number. So which is a better form of representation? Numbers, right? Mostly, okay? Not all the time it is possible. So whatever you have typed, good, very good, excellent, super fine, what type of data is that? Like very good, good, poor, very poor. What type of data is that called? Okay, customer satisfaction, for example, is this type of data. Ordinal data, okay? So similarly, we talk about each and every type of data